Alright, good everyone. This is Mass Intellectuals, and today we are going to continue from where we stopped in our previous video on polynomials. I know in our last class we dealt with some things under quadratic equations and also formulations of quadratic equations. But in today's class, we are going to be looking at some problems under sum of roots and also product of roots. All right, so now before we kickstart, now first of all I want us to look at some expansion which we are going to be needing in this solving some problems in this video. Now let's look at this. Now you have what if, for example, now let's look at some expansion that we have here. We have if you have alpha plus beta all square. Now alpha plus beta square, normally when you expand this, normally you are going to get alpha square plus beta square plus 2 alpha beta. That is, when you solve alpha plus beta and you expand, you will get alpha square plus beta square plus 2 alpha beta. Alright, so now from here, if I make alpha square plus beta square the subset of formula, that means I can bring this one to the other side equals to. So when I bring this one to this other side equals to, it becomes this minus this equals to this. So I've gotten another expansion. Yeah, this one now is now the expansion of what alpha square plus what beta square. Are we there now? Alright. So now another example, another expansion. If you have when you have alpha minus beta all square. Now alpha minus beta all square, when you expand this, you have what alpha square plus beta square minus 2 alpha beta, right? So from here we can now say that what we can make alpha square plus beta square the subject of formula. So that's that. Okay, so then that means that's what we can have this, and then from here when you bring this to the other side, because you have alpha minus beta square plus 2 alpha beta is also equals to alpha square minus beta square. So whichever one you use out of these two formulas is still accurate. All right, so now we also have equation. Let's look at another expansion from equation 3. That is, from here, if you have alpha minus beta all square equals to this, right? Now from here we can bring, that is, we can remove this square root by multiplying both sides by what half 1/2. So when you multiply both sides by 1/2, you know that this one will leave. Or if this square root is being removed and it comes to this side, you know it will become what square root, right? So you have alpha minus beta is equals to square root of alpha square plus beta square minus 2 alpha beta. This one is gotten from equation 3, and then from equation 3 we are looking for alpha minus beta, so we have to remove the square root, and removing the square root to make this way. Are we there now? That means this one is the square is become what square root in the other side of this equation. Now from here, now what are we going to do? Now looking at this, we can still simplify this one further. If you recall from equation 2, we have what alpha square plus beta square equals to this. That means we can replace alpha square plus beta square with this. Are we there now? So we can replace it with this minus what 2 and this minus 2 alpha beta also there. Are we together? Okay, so from here now, what are we going to do here? We have what alpha plus beta whole square minus 4 alpha beta to give us what alpha minus beta, which is also equation 5. Are we there now? So equation 5 is alpha minus beta what root of what this. Are we together? All right, so that's how we got this. Now let's find the expansion of alpha plus beta raised to power 3. So how do we expand alpha plus beta raised to power 3? Now for the expansion of this, we are going to use binomial expansion, now using Pascal triangle. So from here, what are we going to do? Expansion of this, normally using binomial expansion, here you have what alpha raised to power 3 times beta raised to power 0. Are we there now? This one will be descending, while this one will be ascending. The power of this will be ascending, the power of this will be descending, while the power of this will be ascending. Are we together? So plus this one will reduce 1, that's 2. Beta is going to have power of 1 plus alpha raised to power 1, beta power of 2 plus alpha raised power 0 and beta power of 3. So the major thing we are doing here is we are trying to expand this. So instead of using alpha plus beta, alpha plus beta, alpha plus beta, and start expanding, then you expand the top bracket, you can easily use binomial expansion this way and also get the same solution. Are we together now? Alright, so from here now, what do we do? Using Pascal triangle to add the coefficient, we are going to use Pascal triangle. For those who don't have the background knowledge of binomial expansion, I suggest that you have to go and revisit it before understanding what we try to do here. Alright, so from here now we have what? We have this, and we are trying to find this coefficient using Pascal triangle. Now this coefficient power of 1, this power of 2, and this power of 3. How do I get this triangle? What I just did, I have 1 1 1. You have 1 here, you have 1 here. 1 plus 1 give me 2. You put 1 here, another 1 here. 1 plus 2 3. 2 plus 1 3, and you have 1. Are we there now? Like that. The next one will be 1 1 plus 3 4. 3 plus 3 6. 3 plus 1 4, and then you have 1. Are we then as power of 4? But the power of 3, coefficient of power of 3 is this. So this we are going to input to this. That is 1. We have 1 here. Are we then 1 here? And alpha is power 3, beta is power 0 is also 1. So that's how we got this. Plus this one is going to carry. So the coefficient of this one here is what? This. So you have what? 3. Here you have alpha square beta. And the next one is what? Next one is 3, which is this 3. You have alpha beta square. Are we there now? Next one is what? 1, which is what? 1. Alpha is power 0 is 1. That's why you have only beta cube. Are we together now? Alright. So from here, what do we do? So from here, we have what? This as your expansion for what? Alpha plus beta raised power 3. Now from here, what do we do next? So alpha plus beta is power 3. Bring this together. You have alpha is power 3 plus beta is power 3 plus 3 alpha is power 3 plus 3 beta square. Are we there now? Plus 3 alpha square beta plus 3 alpha beta square. Sorry. So that's how we got this. So from here you have this, and from here we can factor out what's common between them. 3 is common, alpha is also common, beta is also common. So we factor out 3 alpha beta. So what do you have left here? You have alpha left here plus what do you have left here? You have beta left here. Are we there now? So we have this. So from here now, this is the expansion for alpha plus beta raised power 3. Are we there now? Also, we can also find the expansion for alpha is power 3 plus beta is power 3 by bringing this to the other side of the equals to. So when I bring this to the other side of the equals to, I have what? Alpha plus beta is power 3 minus 3 alpha beta open bracket alpha plus beta close bracket equals to what? Alpha cube plus beta cube. So alpha cube plus beta cube is now equals to this. All like this, I brought this to the other side, and I have this which is same thing as what? Alpha cube plus beta cube. So this is the expansion for alpha cube plus beta cube. This is the expansion for alpha plus beta cube, and we have expansion for alpha plus minus beta. We have expansion for alpha minus beta square. We have expansion for alpha plus beta square. We have expansion for alpha square plus beta square. Are you there now? And like that. Now you can also try and solve this expansion for. No, I solve for expansion for alpha plus beta cube. You can also solve for alpha minus beta cube using the same procedure. Are we together? Alright, so now let's look at an example quickly. So if alpha and beta are the roots of the equation 3x squared minus x minus 5 equals to 0. Now we have to find alpha plus beta and also find alpha beta. Now recall the general equation is given as this. For general equation, this is a quadratic equation 1, and the general equation for a quadratic equation is written as this, right? So where your ax squared plus bx plus c equals to 0, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Now from the equation we are given, we have this, right? So when you compare both equations, that means your a is what? 3, your b is minus 1, how are there? Your c is minus 5. That's how we got this. Do you get it now? That's how we got that. Now why are we trying to do this? We are trying to find, they said alpha and beta are the roots of the equation. So since alpha and beta are the roots of the equation, from our knowledge of sum of roots, we know that what sum of root, which is alpha plus beta, is what minus b over a, and also product of root is what c over a. That is, sum of root of a quadratic equation is what minus b over a, and the product of root of a quadratic equation is what c over a. Are we there? And we can also use this to formulate or get back this our equation. We did that in our previous video, and if you have not watched that, you have to revisit that also. Now we are asked to look for alpha plus beta, that is sum of the two roots that we get. Now sum of two roots is minus b over a. Now what is our b? Our b here is minus 1, and our a here is what 3. So we have minus and minus. Your alpha plus beta is what 1 over 3. Now what about product of root? That is alpha times beta is what c over a. What's your c? Minus 5, and your a is 3. So your alpha beta is what minus c over a. That's minus 5 over 3. I mean c over a, which is minus 5 over 3. So which is something as minus 1 number 2 over 3. Okay, now the second and the last question which we are going to be doing today is, if alpha plus beta are the roots of this equation here, quadratic equation here, then we have to find the value of alpha square plus beta square. We have to find the value of alpha minus beta, and also find the value of 1 over alpha plus 1 over beta. Since you have alpha and beta are the roots of this quadratic equation, for a quadratic equation you are going to get two roots, that is the first and the second root. So when you find the sum of root, or when you find the square of the first root and the square of the second root, if you add them together, what will it give you? And this and this. So instead of trying to solve this quadratic equation, you try and solve it and get those two roots, and now start squaring it. You can easily use what this approach. Are you there now? So that is the approach you can easily use. Now let's look at this. Since alpha and beta are the roots of this quadratic equation, then that means that we can say that alpha plus beta is minus b over a, where your a is what 2, b is what minus 1, and c is what minus 2 from here. Are we there now? So what is now alpha plus beta? Alpha plus beta is minus b over a, and alpha plus beta here is minus b is what minus 1. So we have minus b is minus 1 over a, which is 2. Are we there now? Which is going to give us 1 over 2. And what about alpha beta? Alpha beta is c over a. C is minus 2, and a is 2, which will give us minus 1. Are we there now? So this is sum of root and this is product of root. We are still going to need these two. Now going back to the question you are given, you have to find alpha square plus beta square, right? So since we have to find alpha square plus beta square, then if we recall from our previous equation, that's equation 2 or thereabout, that's what from equation 2, that was alpha square plus beta square is equals to what? Alpha plus beta square minus 2 alpha beta. So we are going to bring that into this now. So we know that what we are looking for alpha square plus beta square, and the expansion for this is this already. So from here now we know our sum of root is what? Alpha plus beta is 1 over 2, and the product of root is what? Minus 1. So we have what? 1 over 2 square give us 1 over 4, and this will give us what? Plus 2, which is something as 2 number 1 over 4, which gives us the answer to that. Question 2 says that we should find what? Alpha minus beta. So to find alpha minus beta, if you recall from our previous equation, the alpha minus beta is what? Root of this, right? So you look at it here, you see that equation 5, see that alpha minus beta equals to root of what? Alpha plus beta square minus 4 alpha beta. So that's the same thing we are going to use here, that alpha plus beta, alpha minus beta equals to this. Now we also already know the formula for, or the value for alpha plus beta. The value for alpha plus beta is 1 over 2, and then you have square minus 4. Alpha beta is what? Minus 1 from our equation, right? So we just input the value, we have this. So this will give us what? 1 over 4, and this will give us what? Plus 4. So adding this one together, you have 17 over 4. Square root of 17 over 4 give us what? Root of 17. Root of 4 is what? 2. So the answer is what? Root 17 over 2. Are we together? Alright, so now how do we now find the third one, which says that we should find what? 1 over alpha plus 1 over beta. So for 1 over alpha plus 1 over beta, first of all we need to find the LCM. What's the LCM of alpha and beta is what? Alpha beta. When you alpha divided by alpha beta divided by alpha will give us what? Beta. Beta times 1 give us beta. Alpha beta divided by beta will give us what alpha. Alpha times 1 will give us alpha. Just the way you same way you solve for fraction, addition of fractions. So we have this. So from here, what do we do? What is this one can also be written as what? Since addition is commutative, that means we can exchange this. That means you have alpha plus beta over alpha beta. So what is alpha plus beta? According to the equation we have solved, alpha plus beta is equals to minus 1 over 2, and alpha beta equals to what? Minus 1. So coming back to this equation here, we have what? Alpha plus beta equals to what? Minus equals to 1 over 2, right? Is equals to 1 over 2, and alpha beta is equals to what? Minus 1. So here you have what? Eventually you have minus 1 over 2. Have it together. So this is how you solve questions under what? Sum of root. You have other questions we can try. Under sum of root, you can be given a question. If this and if alpha and beta are the roots of an equation, find the sum of roots, find the product of root, find the sum of they just give you an expansion whereby you have to expand it and you have to now solve to get the sum of roots and all that. But most of the times you can be given something like this. You can be given find what? Can be given find alpha cube plus beta cube. That is when you have the two roots and all that. So you need the expansion. So I've given a little basic background on how you can expand some sum or products of some roots, and these are some of the major ones. This one you can still expand further. You can find alpha plus beta is power 4, like that, using binomial expansion and all that. So these are some of the basic things you need to understand on the sum of roots and also product of roots. So I'll be seeing you in my next video. Don't forget to like, subscribe, and also share this video. Thank you.